I've had a few people ask me what control system that I've been using in my From Loop to Layout series. Am I using DC? Am I using DCC? And what are those anyway? Well, we cut through the jargon and we even give a short review on the one that I have settled on, coming up on JC's Rip Track. Hi there, my name is John and welcome to JC's Rip Track. If this is your first time here, this channel is all about advice and tips on how to transform your plastic models into something that looks like it belongs on the rails today. And if you want to follow along, then please click on subscribe and that little bell icon and you can receive a notification every time there's a new video. So, do you use DC or DCC on your layout? Are you confused as to what those mean? Let me know in the comments section below. Model railroading is a multifaceted hobby. My primary focus, as is the focus of this channel, are ways of making your locomotives, rolling stock, models, and scenery to look as realistic as possible. That's where my strengths lie. But in truth, if I want stuff on my layout to move around, I need to know at least a little bit about how it all works. So what I'm sharing here is about how control systems work, not as an expert, but from the point of view as one who wants to have my weathered trains moving around the track. Many of you are much better at electronics than I am, but there are probably many who aren't sure. And so I'm going to share with you with what I use and why, and what the benefits of each are. So I'm going to start with some basics. It may not be obvious, but in the videos from the Loop to Layout series that I've published so far, you have seen me use not one, but three different control systems. One DC and two DCC. But what do those terms mean anyway? DC stands for direct current and is the original way to operate model trains. Up until 1989, it was the only way. The principle is relatively simple. Direct current uses a controller that converts 120 volts of alternating current from a household electrical wall plug into 18 volts of direct current. In the UK, it'd be about 240 volts. This power pack feeds the current to two rails on the track with a dial that changes the voltage level. Sometimes it's called analog control, but DC is the abbreviation that is used most often. Now here's a little sidebar. For those of you who are not familiar with electricity, the voltage is like pressure through a pipe. The higher the voltage, the higher the electrical force. Current, on the other hand, is like the volume of the water. Model railroad tracks are fancy-looking exposed wires. The locomotive connects to these wires when it is placed on the track and it completes the circuit. The electricity is picked up by the wheels of the engine, powering the motor. And the higher the voltage, the faster the motor spins and the quicker the locomotive will go. All trains present on a given track will travel in the same direction, regardless of what direction they are actually facing. With direct current, you are not controlling locomotives, you're controlling power to the track. It's still the least expensive option for running model railroads, but it does mean that one can only have one train on a track controlled by a single controller. Things get much more complicated very quickly when you want to run more than one train at a time, as the track has to be divided up into separate blocks powered by independent controllers. However, with direct current, you cannot run two locomotives up to each other, as they will always move in the same direction if powered by a single control unit. All of the Cato Unitrack starter sets that include a train and a power pack are DC or direct current, and the locomotives that come in those starter sets are all built to run on direct current. On the other hand, while the initials may sound similar, DCC is very different. It stands for Digital Command Control and works on a very different principle. The only similar thing is that DCC works with approximately the same maximum voltage level, but that's where the similarity ends. With Digital Command Control, the voltage is a constant 15 volts, which is about the same as a direct current power pack turned up to almost maximum, but it is alternating current rather than direct. The reason that the locomotives don't suddenly fly off the track is what the voltage and the current are actually doing. Unlike direct current, DCC sends command signals through the track that are then picked up and interpreted by a small dedicated computer board called a decoder installed inside of the locomotive or other device on the system. The decoder interprets the signal first by determining if it needs to listen to a given command, and if it is, by carrying it out. This process happens almost instantaneously, so someone operating a train sees this as the locomotive responding as they manipulate the controls. While it is more expensive to be sure, digital command control allows one to control trains like the real thing. Several locomotives can operate independently on the same piece of track. The lighting on an engine is independent and it can be turned on, shut off, or even dimmed and point in the direction the locomotive is traveling. Also, the advent of decoders that use sound has created a much more lifelike experience in that locomotives can now make noise as they carry out their work on the tracks. Engines can also be paired up and work together as a single unit called a consist. And while you can easily do that with direct current, one can also add or drop locomotives as to the consist as they need it. The sophistication level for this is quite high, and yet the wiring is not that complicated if you're starting out. From a beginner's perspective, it's easy to make the switch from direct current to digital command and control. All you do is disconnect the wires that you had attached to the DC power supply and connect it to the DCC one. Now, you do have to make sure that the locomotives on your track are all equipped with decoders. So I recently replaced my older DCC system with a newer one. I decided that after 15 years, it was time to upgrade my Prodigy Express. I looked at several different systems, and the most commonly recommended ones in North America are from Digitrax or NCE, but more recently I've been impressed with the European-made systems. German-based ESU makes some of the best sound-based decoders for locomotives, so the hardware from this company is something that caught my attention. In particular, the cab control system that integrates the mechanics of an Android-based smartphone with a train control system. In researching this, I learned that Piko is spelled P-I-K-O as opposed to P-E-C-O, also another train company. Their smart control system is the same hardware as ESU's cab control system, and for me, the price was right. I took it home, I set it up, and I was immediately impressed by how easily it was to use. Not only that, any locomotive that is equipped with a decoder that has the Railcom feature like ESU's lock sounds, the system automatically detects it, and it provides a profile for the controller complete with all of the appropriate icons. For older decoders or those without Railcom, you still have to set up the locomotive profiles in the old-fashioned way, but I have to say, even then, it's very straightforward to use. You can use and set profile pictures of the locomotives in question, and the Piko version of this control system is mostly European-based locomotives as well as generic icons, which work in my case. The cab system works by setting up a separate Wi-Fi server that the hand controller connects to. It also has the capability of being tied into a larger network through an Ethernet connection. You can also use LocoNet and all sorts of peripherals that are part of that system. So in that sense, it is compatible with a very wide range of products. The full functionality of the system comes into play when the smart box can connect to the internet. And while it has its own built-in Wi-Fi, it can also use the Ethernet cable to plug directly into the internet connections that you have in your home. This way, it keeps up to date with any updates. And I'm still climbing the learning curve on this for much of the technical aspects. For example, it appears to have some functionality to allow smartphones to connect with it, but I have to do a little bit more playing with it to get that part to work. What matters, however, is that the process of taking it out of the box, connecting it to my layout, and running a locomotive was very smooth. It connects very quickly to any locomotive that already has a lock sound decoder in it, and programming profiles for other engines is quite easy. For me, this is a good investment, but I still need to learn a little bit more, but it has the expansion ability for what I need. So while this series isn't quite my usual weathering fare, I thought this could be helpful to anyone getting started in the hobby. Plus, it has me building and operating my layout. If this is something that you find useful, then please click on subscribe and the little bell icon that appears if you want to receive notifications anytime I put out a new video. If you click on the show more in the area below this video, you can check out some of the helpful links either on social media or on my Amazon page that features some of the track and the control systems that you see here in case you can't find them at your local hobby shop. So thanks so much for watching, good luck, and may you keep on track.